The Physical Layer, Chapter 2 in Computer Networks. MEO or Medium Earth Orbit Satellites. So this is LEO, here we have GEO. In between, this is the Medium Earth Orbit. We have known about the Van Allen belts. So it leaves us only to these regions. So the intermediate between LEO and GEO is MEO. The region between LEO and geostationary orbit. The altitude is from 2000 to 36,000 km. The orbital period, that is to cover all the orbit, is 2 to 24 hours. Larger coverage area than the LEO and very good for the communications. But the disadvantage is the high levels of space radiation in this range or this altitude. The global positioning system, different GPSs, they have satellite here. So MEO, Medium Earth Orbit satellites, between the two Van Allen belts that we have discussed, where the satellite will actually burn, these MEO take around 6 hours to circle the Earth. Since it is higher than LEO and lower than GEO, they have smaller footprint on the ground and they require less powerful transmitters to reach them. Footprint is the area it can see, the area it can communicate. Okay. So it has a smaller footprint than GEO, though higher than the LEO. And this range, MEO, is used for navigation systems rather than the telecommunications. And in this area, as I said, whichever GPS you know, for example, the Navstar or the American GPS, they have 24 satellites every time they are active. So you get 3 satellites, you get the exact position of yourself. So there are 30 GPS, there are around 20,200 kilometers from the Earth's surface. These are MEO satellites. LEO or LEO satellites. LEO. The name itself suggests that they are the nearest to the Earth's surface. The distance or the altitude from the Earth's surface is 375 to 1000 miles. That is, the orbital range is from 500 to 1500 km above the Earth's surface. So this is the nearest to the Earth's surface. The revolution time is around 90 minutes to 3 hours. And most important thing is these LEO satellites, they don't stay in fixed position related to the surface if you are standing. They are only visible for 15 to 20 minutes each pass. So there are certain advantages also. That is, the transmission delay is very less as compared to the GEO and MEO, and it will not need bulky receiving equipment as was in GEO. The disadvantage is it has smaller coverage area. Why it is smaller coverage? Because it is quite closer to the Earth. So you can say the field of view is also less. The GEO has around lifespan of 10 years, the satellites. This LEO has around 5 to 8 years. So we have a subdivision here, little, big and mega LEOs. And since it's quite closer to the Earth, so a network of LEO satellite is necessary for LEO satellites to be useful actually. So LEO is low Earth orbit satellite. We need large numbers of these satellites in order to complete a full constellation for a complete system. And since they are very near ground station, do not need much power. As compared to the MEO and GEO, the round trip delay is also less, that is around 40 to 150 milliseconds. This is the round trip. You can also call it as the latency. That is the time signal is sent and it is received. This is around 40 to 150 milliseconds. While if you talk about the geo, if you use VSAT, it's around more than 500, sorry, 500. So whenever we talk about the communication, we have two, the constellation or the project. First is the Iridium, and the second is the Global Star and Iridium. So they are very popular and they give a lot of services right from voice to paging, fax, the location, etc. Iridium is a low Earth orbit satellite constellation. So this Iridium, actually what happened? In 1990, Motorola came up with an idea and they filed the application with the FCC, the Federal Communication Commission of United States, and they asked for the permission to launch 77 LEO low orbit satellite for this Iridium project, because the 77 element is Iridium. And this was the first time something of this sort has happened. So it was later revised to 66 satellite and the project was renamed as Dysprosium. The element is 66, but still we know it by Iridium. Now, this idea was like this because this idea was became very popular and buzz in this satellite industry. So the idea was that because it is LEO, LEO remains in view for 15 to 20 minutes, not more than that. So if one satellite went out of the view, the another should replace it. This was the idea. After all the formality, the service began in November 1998. But the problem was, it was very unfortunate that from the 1990s, the mobile phone network has already grown exponentially. So the commercial demand for large and heavy satellite phones were very less, or you can say very negligible, and it was very unfortunate for this Iridium project. Commercially, it was not so profitable. It was non-profitable and was forced to file a bankruptcy in August 1999, this Iridium. Okay. But, before they can sell, they are selling it actually, satellites and other assets. It was worth 5 billion and it was purchased by an investor for just 25 million. But, if you do something with whole heart and something is promising, it pays later. So Iridium, it restarted in March 2001. And since then, it is topping. That means it is providing voice, data, paging, fax, navigation service everywhere, anywhere on land, on air, on sea, via the satellite handheld devices that can communicate directly with the constellation, that is the Iridium satellite. This is one of the Iridium satellite we are witnessing. So customer include wide variety. It is maritime, the aviation, the oil exploration industries, and even the individuals who want some navigation or connectivity when they are at a place where there is no connectivity. This is the Iridium project. So in this Iridium satellites, these are from above Earth, above surface, they are 670 kilometers. And they are in the circular polar orbit. Please understand, they cover the polar because the global master, it doesn't cover the polar. So they have the circular or polar orbits, and one satellite is there every 32 degree of latitude. Every 32 degree there is one satellite. Each satellite has a maximum of 48 cells, that is for the spot beams, and has a capacity of 3840 channels. So these channels, some of them are used for paging and navigation, and some of them are used for data and voice. So, you have seen the necklace, normally the women wear it. So this necklace they have pearls also. So you can imagine the constellation as different necklaces with these pearls as the satellite. So communication between customer, they take place only in space. For example, a North Pole person is calling. It is going to call the satellite directly overhead. Each satellite has 4 neighbors, as you see here, the 1, 2, 3, 4, which it can communicate. 2 from the same necklace and 2 from the adjacent necklaces. Necklaces means the idea I showed you. So the satellite relay the call across these grid until it finally is received or sent down to the callee at the South Pole. So the communication happens on the space, takes place in space. Global star or low Earth orbit satellites. So this global star, the constellation of satellites are in Leo orbit. The global star is a low Earth LEO satellite constellation for satellite phone and low speed data communication. The global star orbits have an inclination of 52 degrees. That is, they are not covering that much of the polar area. Because on the left hand side you see this is the figure of iridium. It covers the polar area quite nicely. So the global star orbits have an orbital height of approximately 1400 km. So we have 48 LEO satellites in global star, and global star uses a traditional bent pipe design of communication. If someone is calling from the North Pole, it is sent back to the Earth because it is the iridium. All the communication take place at space. Here the call originating from say the North Pole is sent back to the Earth and then picked up by the large ground station, and call is routed now via a terrestrial network on the ground to the ground station which is nearest to the callee, that is who is supposed to receive the call, and it is delivered by the bent pipe. The advantage is that in iridium all things are happening on space. So if something has to be maintained, you have to go to the satellite, and that is not so easy. In the global star, it put much of the complexity on the ground, so it is easier to manage. Okay, you talk about electric, electronic, or electromechanical devices. So use of a large ground station antenna that can put up or put out a powerful signal, and they can also receive a weak one, means that the low powered telephones can be used. The actual handheld devices are not having that much of power. What happens? The academic researchers from California Polytechnic University and Stanford, I'm talking about United States, they got together in 1999 and they defined a standard for the miniature satellite. We are talking about 5000 kg satellite, but here they decided that we'll have a miniature kind of satellite, and that was called, I'll just show you that this is a size of a cube. This sees like a cube, so they were called as CubeSats. CubeSats, that's for satellite, and these are satellites in units 10 centimeter by 10 centimeter by 10 centimeter. If you type CubeSats right now, you will see Canada is leading now. So this is a very small size. You see the weight is just over 1 kg. The size is only, or the volume is 10 centimeter cube. The size, the weight is not more than 1 kg, around 1.25 kg. And the price for this one is $40,000, and it can communicate with ground station on the UHF and VHF band. So these satellites are put as a payload to different big satellites which are being launched, and they act as a payload and they just work the similar way the other satellite would work. Okay, UHF and VHF band. Now one more thing you need to know, at the low Earth orbit is OneWeb. Boeing and various other, they have started it. So another deployment of this LEO satellite is an attempted satellite-based internet backbone network. Internet backbone network. This is a very challenging and you can say encouraging kind of project, OneWeb. So the constellation has innovative beam technology. They have small inexpensive satellites using existing technology. Around 900 satellites are to be produced for OneWeb. And at ground we have affordable compact multi-user access terminals, easily installable without the position aiming, and we will have gateways across the globe for this OneWeb. OneWeb, if it is successful, it promises to bring high-speed internet access to every place, especially to the developing countries. Satellite will operate in K upper or Ku band and will use a technique called the progressive pitch. What does it mean? Here the satellites are turned slightly to avoid interference with the geostationary satellites that are transmitting in the same band. So this will be the progressive pitch. OneWeb, the backbone, internet backbone network, satellite based at LEO. LEO, MEO, GEO. So low Earth orbit, medium Earth orbit and geostationary Earth orbit. What are the differences? First we'll start with the LEO. So LEO satellites, they are at the altitude of 160 km to 2000 km. Full orbital period, that is the time it completes full orbit, is around 88 to 127 minutes. The latency, that is the signal when sent and received, the round trip is approximately 2 millisecond to 27 millisecond. Now coming to the medium Earth orbit, MEO. These are at the altitude of 2000 km to 35,786, that is 36,000 km. Full orbit period is around 127 minutes to 24 hours. Latency is 27 millisecond to 477 millisecond. Coming to geostationary. Geosatellites, they are at the altitude of 35,786 km to, just remember, you can say 36,000 km. The orbital period is 24 hours, that is, it will be seen stationary, that is the same time the Earth revolves. Latency, the round trip, is approximately 477 millisecond for geostationary Earth orbit. So what we have discussed, the satellite height, LEO 500 to 1500, MEO 5000 to 12,000, GEO 36,000. The orbital period we saw, and we can have a good idea about LEO 10 to 40 minutes, MEO is around 8 to 20, 2 to 8 hours, GEO is around 24 hours. So number of satellites in LEO requires higher, 40 to 60, in Iridium it is 66, at 8 to 20 in MEO, and in GEO, because it covers almost 42.2 or 43%, we need 3 GEO to cover whole Earth. The satellite life of LEO is short, around 5 years, GEO is around 10 years, MEO is in between that. And there are two electronic aspect, communication aspect, number of handoff and propagation loss also. The gateway cost in GEO is cheap. LEO, it is quite expensive, very expensive. Now let me tell you about the merits and the demerits. In the LEO, the merit is the cost for launching is lower than the other two. And since it is very close to Earth, very short round trip delays or latency is there. And since the path loss is quite less than the other two, MEO and GEO. When it comes to MEO, the merits are the launch cost is between LEO and GEO, that is moderate, and the round trip are quite smaller than GEO. As I said, GEO, it is covering around 43%, 42.2% of the Earth's surface. So you need less satellites for that. We have constant view because it is already 24 hours the Earth time and its own time. No problem due to the Doppler. Coming to the demerits, LEO has a short life, 5 years. And because the distance at which it is placed, the LEO satellites, they encounters radiation belts. and it has a short LOS, the line of sight, and the loss also. The loss is also there. Then in comes to MEO, the demerit said the round trip delays, and it has the greater path loss as compared to the LEO. Okay, communication you are doing, so there will be a path loss. Then coming to the GEO, the larger round trip delays, as you see, 477 millisecond, and we need expensive equipment due to weak signal. Okay, this is all about this topic. Thank you so much. Take care of yourself.